All right, we've got a golfer. They shoot the golf ball. They have a really good swing. This is 53 meters per second at 40 degrees. The very first step when you're doing a problem like this is to find Vx and to find Vy. And we use trig to do that. This is going to be V times the cosine of theta, and this will be V times the sine of theta. So when we plug that in, that's 53 times the cosine of 40 degrees. You want to make sure that you are in degree mode. If you are not in degree mode, that is bad. If you're in radian mode, you'll get weird answers. So make sure that you're in degree mode. Your math class may have you put yourself in radian mode pretty frequently, so just be aware of that. And then this is 40 degrees, and that's going to give you 34 meters per second. So then, what do we know? Well, in the x direction, we know Vx is 40.6 meters per second. And that is it. That is what we know. In the y direction, our golf ball is going to move up, and then it's going to move down. We know the initial speed that it's traveling is 34 meters per second. And it seems like that's all the information we have, but we also know that the speed at the top is 0, and the acceleration is going to be a negative 9.8 as it moves up against gravity. That allows us to find the time that it's going up. We know that v is equal to v0, whoops, that's not another equal sign, that's a plus at. So rearranging that, t is equal to v minus v0 over a. And t up will equal the speed at the top minus the speed it starts with, divided by that acceleration, negative 9.8. That's going to give us 3.47 seconds. And then we can find t air by doubling that, since it's going the same amount up as down. Notice all the work I'm showing here. Please do that too. Okay, so that was the first part, was to figure out how long it goes in the air. To figure out how high up it goes, there's two different ways we can do that. We can use y is equal to y0 plus plus v0t plus 1/2 at squared. This, there isn't one. We've got 34. We want to use the time up because we're looking for the maximum height. We don't want to know how high it is here. In fact, we should get 0 if we use the whole time in the air. So we want to use the time up because that's where it is the highest. So that's 3.47 seconds, and that's plus 1/2, a negative 9.8 times 3.47 squared. And that would give us 59 meters. The other way you can do this is using this equation. V squared is equal to v0 squared plus 2ay, and solve for y. So v squared minus v0 squared over 2a. And then you can plug in, that would be 0 minus 34. Notice I'm never using that 53 that they gave us ever again. Once you plug it in, you don't use it again. Or once you plug it in and get your components, you're never going to use that value again. And you can see we also get 59 meters going this way. So that was the second part. How high up does it go? In order to figure out the last one, the horizontal range, we're looking for x. X is equal to x0 plus v0t plus 1/2 at squared. We use this equation a lot in 2D motion. In the x direction, there is no acceleration. That is also 0, so x is going to be equal to vx times t. And this is going to be 40.6. And then here, because we want the entire distance that it's traveling, so this whole thing right here, we don't want just the time up. That would only get us to here. We want the whole time in the air. So we're going to use the 6.94 seconds. And that is 282 meters, which is a long shot.